I'll go for it. Yeah. Okay, let's get started. Welcome back. We are officially going to start our unit on proofs. Yep. So you have some notes, and on your desk you have proof blocks, which will help you structure your proofs in a way that they all make sense and work together. Okay. So our eventual goal of what a proof looks like is this. Okay. It's basically what we've already been doing, but we're writing everything out. A lot of times we were solving problems and marking up our graphs, like we saw MT is perpendicular to AH, and we go ahead and mark these and say, oh, those angles are congruent, without actually writing that down. And we might see things like H is the midpoint of MT. Well, H is the midpoint of MT. Oh, that means those are congruent. We never actually write down MH is congruent to TH. We wouldn't write all the little things down. We just assumed everything. So a proof just writes everything down that you're thinking when you're solving all those side, angle, side, angle, angle, side, 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 side. It's just formally writing everything down to be very clear, to be very complete. So when we're doing these, just think about that. Not really anything new that we're doing. It's more about just being thorough and writing everything down. And how do you know you're doing everything thoroughly and not forgetting anything? That's where the proof blocks come in. They actually structure everything to make sure we're not forgetting any pieces of information. Okay. Now, furthermore, you have to have these reasons on what they're actually called. And that's what the proof blocks also help you with. You already know like side, angle, side really well, but reflexive, we haven't really kind of written that down too often. Definition of perpendicular lines, we haven't written anything down like that before. You might have been doing the work using that theorem or postulate, but not knowing what it's actually called. So now we're just going to use the actual names of everything. Okay, think of this in a similar way to what a lawyer would do when they're citing court cases during the case. A lawyer has to know all these court cases that happened before that's related to the case they're working on. So when they're actually in in the middle of a jury or something like that, they can actually cite things from a long time ago saying, oh, from this court case, we know this is to be true, right? This will help us prove our case. They know all this different information, background that's related to that case to help them out, okay? So the more theorems or lawsuits and court decisions they know, the better equipped they are to actually, run a trial and win a trial. Okay. So before we get started, let's look at the structure of these. Okay, we use something called the law of detachment, which is basically like a if-then statement, cause and effect relationship. So on these proof blocks, if you want to take them out of the bag and take a look at them, each of them has a name on them. It's either the name of a theorem, a definition, a postulate, or some property that has an input on the left side. Okay. And output on the right. Okay. So the way you use these is you take the statement that you're given and you see if it matches up to the format of the left-hand side of any one of these. So since this statement right here is in this format of angle, letter, 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 congruent to angle, letter, 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 right? That's the same format as this, just with the actual letters. We know if we put this statement into this definition, the result will come out the right-hand side, which means the measurement of ABC is equal to the measurement of angle XYZ. Okay. So that's how we use these. Okay, just look for the format on the left side of each one of those proof blocks and see if it matches with the right-hand side. Okay. So going down to the next one, you'll see that here, does this format match the left-hand side at all?
Thank you.
Okay. Does this format right here match the left-hand side of these? Right. Now, this says two angles are congruent. This is saying this one angle is a right angle or this one angle is a right angle. So yeah, this does not work. So it's important to understand that the format needs to be exactly the same, just without the letters, like it was here. Angle ABC congruent to angle XYZ, it's the exact same format, just without the letters. Exact. Okay. Here, up here, it does not say PQR is a right angle or DEF is a right angle, so we cannot use right angle theorem for this particular statement. So this helps you narrow down what you're allowed to use and what is not going to be useful to you. So you'll be going through all these different stacks of different colors of these proof blocks, kind of looking through them and seeing, well, which one matches the format properly. So in this one we say, it says write no conclusion, right? So we'll write no conclusion if that happens, but no conclusion. But really, what does that mean? We can't use this. Okay? Can't be used for this statement. We cannot use this for this statement because it does not match. So let's give you a little situation how we're going to use these. So you can spread these out. You'll notice we have different colors and everything here. Okay. We have this question of the proofs are usually two parts. We have a given, which is free information, and we have what we're trying to prove. This is the last step of every single proof. This is the last thing we're going to write. So if we do everything right, we're going to be able to say this, and once we've said this and proved this, we're done with the problem. Okay, so whatever's listed after prove is exactly what you're trying to end up with. Okay? Now, let's go through how we were doing these before. Okay, if we're trying to say that these two triangles here are congruent, what did we do in the past? Okay, we usually took the information. Sometimes it's already marked up for you. These are not marked up. But we take the information like XM bisects YXZ. And then we say, oh, if this is bisecting this angle right here, that means these two angles are congruent. They would put a mark there. Right? And then if we had another statement right here that said, oh, XY is congruent to XZ, we would mark that up. And then we look for one more piece of information because all our theorems have three letters. We need an angle side angle, an angle side, a side side side. Right now we have two. So we tried to look at the picture and say, is there anything else that's congruent that we can get just by looking at the picture? And one of the things that we figured out is that if triangles are sharing a side, XM is on both triangles, right? It's the leg for this triangle here. It's also the leg for this triangle here. So it's congruent to itself. XM is congruent for the top triangle. It's congruent to this bottom triangle. Okay, and that was called the reflexive property. So this is nothing new. And then we looked at this and said, okay, that's a side, that's an angle, and a side. So we said, by side, angle, side, these two are congruent. Right? So we already have the structure of what we're doing. Now we're just going to actually put in all the definitions and all the theorems and write it out in a more structured way. Okay. So here's what we do. Let's start up here. Find the card that matches this format. That it probably looks like this. It has an open box, right? It's basically the same thing, but has open boxes. So segment blank blank. is a bisects or is a bisector of angle. So you're going through and finding where is that particular card, looking at all of these. Okay, so go through each one, see if you can find it. I'll show you. Okay. So what did you come up with? Probably something that looks like this. So if we look at this carefully, you see how it has blank blank is the bisector of angle blank blank blank. That's the same exact format as we have here. So for this, we're going to use the definition of an angle bisector, which after a while will be very obvious. Bisects an angle. Definition of angle bisector. You're not going to be going through each one of these. I wonder if it's midpoint when it says bisects an angle. You're going to go straight to, well, angle bisector. So just know that it'll get easier identifying which ones you're supposed to use. Okay? And I mentioned, let's see here, this one where they just tell us these two are congruent with no reason why. That's what we use the given for, these G's. Okay, so the G stands for given. Now, we don't have to have a reason. They just told us it's true. So we say, okay. Lastly, from the last one was that XM is equal to XM. So we just looked at the picture, the P, okay? And then from the picture, we said these two segments are equal to themselves, and that's called reflexive. Okay, so that's called reflexive. And again, the more you do these, the easier it gets, just kind of identifying what is congruent to what and why. So we have three different statements right now. We have these angles are congruent based upon this. We have this is congruent to it because it's just given to us. And we know from the picture and the reflexive property that this is congruent. So at the right end of these, we're just going to write that down. Okay. There we go. Okay. So here's what we're going to do. So this statement, if we put it into this theorem, the outcome is what two angles are actually congruent by the theorem. So we marked them already in red. So YXM, okay, is congruent to ZXM. Okay, that's what this theorem or definition tells us. We have this information. This definition tells us this is true coming out. Okay? So we have one of the angles. We have the angle congruence statement for our angle side angle. Oh, yeah. Right. And we have this given statement right here. And then from the picture, we can look at it, use the reflexive property. We already marked it here, XM. Segment XM from the top triangle is congruent to segment XM in this bottom triangle. It's congruent to itself. We just write it out formally. Okay. Now I know it's scattered around a little bit. Okay. But we just satisfied everything we need for this angle side angle postulate. Okay. To use this postulate, we did an angle, side angle side. Angle side angle. There it is. Side angle side postulate. There we go. There we go. And here's how you'll draw these out on your papers. Say, well, from here, this angle, that goes in here. But you see there's 3 empty places, right? That's why there's one for each of these. We need a statement for the side, a statement for the angle, a statement for the other side. So we have another statement right here for a side. And we have our second side, our third statement right here. Okay, so since we have all 3 statements going into this postulate, the outcome of that is right here. What we're trying to prove. Triangle XYM is congruent to triangle XZM. Okay, and that completes our proof. Now, as I mentioned before, we're going to change this into a 2-column proof eventually, but at least this way we can see how everything works. And when we're using a postulate that has 3 letters, we have to have 3 statements before we use this postulate. You can't just use it anytime you want. You have to do all these 3 statements, really in any order you want. It doesn't matter if I do the side, then the angle, then the side. I can do the side, then the angle, or so on. But it's a little bit easier when we do it this way, when we do it in the order of the actual postulate. Okay. All right, so let's practice just a few more and really get this down. And using all these, again, this is when it's given. This is when we just look at the picture and get it. And then all these when the format actually matches some statement. Okay. All right. Now, if you want to, if you're doing these like we have been doing, you can just really plan out this whole thing from the beginning and work backwards. There's a couple ways of looking at this. And so before, we would just mark this up and say, oh, N is the midpoint of NB, and say, okay, that's congruent to that, right? So if pretend like AB is 10, if N's the midpoint at 5, each one of these is the length of 5, right? Or if this is 6, N's the midpoint at 3, each one is 3, right? So it doesn't matter what the measurements are. If N's the midpoint, these 2 must be congruent, right? And then we have just a couple of givens, right? Angle DAN and CBN are congruent. Then we'd mark these. And then we have a second given. Givens are just congruent statements that with no reason given, it's just automatically assumed to be true. So DNA, so right here, and CNB. Right? So right away you can see that this is an angle, side, angle, right? Congruence. So we can actually start at the very end and know we're using angle, side, angle, and have that ready to go. Get these out of here. And we already know, because of, we can already see what's going to happen here. We already know that this is going to end up proving that these triangles are congruent. So it's not a surprise what's happening at the end. We already know the end result. It's just that some people find it easier to work backwards. Because I know this is what I'm trying to prove. And by looking at the picture, I can see it's angle, side, angle. Now I know, working backwards, I need an angle congruence statement, I need a segment congruent statement, and then another angle congruent statement. And you can just go work backwards from the givens and figure out how to get those 3 things. So it's kind of like you already know, it's like making a checklist of the 3 things you need to finish this problem. Okay, so anyway, it works for you. And some of these we have not talked about yet, so don't worry about the ones we have not done. We'll use them soon enough. So we did touch on the corresponding parts of congruent triangles, of course. We have seen vertical angles, right? So that one we have seen. And the one below it we have seen. But I know I don't need these because I already have my graph marked up, and we didn't use vertical angles and we didn't use reflexives, so I don't need those. Only thing I really need to do is figure out this one. N is the midpoint of AB. Okay, and which definition would that be? The last one was an angle. This is a segment, so a midpoint of a segment. Okay, and you can look really closely here and see this right here is the same exact format of this statement. So I know I need to use this definition of a midpoint. Everything else, I can just kind of move out of the way. See if this will. Doesn't want to go. Okay. Right. And I'm not going to get anything from the picture. Right. I didn't need to mark any reflexive or anything, so I don't need that. I do have a given, so I will use that. So let's go ahead and mark these up. Here's how this should look. I'm going to take this statement. It's going to plug into here. Right. And when I plug this statement into this definition, the output is what's actually congruent to what. So look at back at your picture. AN is congruent to NB, which satisfies this segment part of my angle side angle postulate. And then we know right here that's given to us that angle DAN is congruent to angle CBN, and that satisfies this angle here. And third, we have this other that's just given. So I actually have two givens here. So I'd use two G's. Get these out of the way. No picture. There we go. So my third statement would be just that. Angle DNA is congruent to angle CNB. Since I just got my third congruent statement and I've already done the ending of it, right, I am finished. Got it. So keep that in mind for all of these. We're not using HL just yet, but so all of these, they have three statements, right? So I know I'm done because I have a postulate or theorem here that proves the triangles are congruent, and then I have all three of those statements. Now, I've been purposely doing these in different colors so you can see very clearly there are three different statements, right? When you just write this all in pencil and everything's the same color, it can sometimes get a little confusing of, well, do I have everything I need? So if you want to use highlighters after you have written these out, when we start doing the two columns and actually color coding everything to know that, yes, I got the side, yes, I got the angle, yes, I got the other angle, you can do that. Okay. All right, so I'll let you guys try this. Okay. Work together. You guys can work in pairs or all four or three of you in groups right now and decide which ones you have to use and go ahead and write it all out. You've probably seen here that once again we have AN bisects an angle. That matches the definition of angle bisector on the left-hand side. Okay. So let's go through and mark that up. If I plug this into this definition, the outcome will be, we can do the graph right here, AN bisects, so these must be congruent, C and A. Right? And I and A. Okay. our next statement was just given to us that it's congruent already. We didn't have to use any definition. It's already congruent. We can mark the graph here and here. And then lastly, what else is congruent? Just by looking at the picture, and why? Yeah. Yeah. AN is congruent to AN, right? Because of, again, that reflexive property. So from the picture, we can use the reflexive property and just say that segment AN on that left triangle is congruent to the segment AN on the right triangle. So we have three congruent statements: an angle, a side, and an angle. Okay. Two of them we had to kind of figure out using definitions and properties. One of them was just given to us. Okay. Now the question is this an angle, side, angle, or angle, angle, side? By looking at the graph, which one is it? Okay. So basically this. You see how for this postulate the side is in between the two angles? For angle, side, angle, it's in the middle of the angles, right? So in this picture, is the side between the two angles? No, right? So this is not angle, side, angle. This is angle, angle, side, because it has the two angles and then the side at the end. So angle, angle, side. So you got to be careful because both of these have two A's and one S. So you're looking at, is the side included between the two angles or not? So if the side's not between the two angles, like it's not between C and N, then we're not going to use it here because it's between the two angles. So we want to get rid of that one and use angle, angle, side. And that is a common mistake. So if anything else, if you're checking your work, be very careful. Make sure you're using those properly. So we have an angle. Right. I have another angle. Now, it is okay that we use a one-letter version and not the three-letter version. We could write a three-letter version of these two angles instead of just C and I. We could say NCA and NIA to get the same format, but it's okay if it's non-ambiguous. And then lastly, we have the sides. So we have angle, angle, side, which proves that triangle CAN is congruent to triangle EN. So with these proof blocks, there's no way to forget something, because if we only did two of the congruencies, we wouldn't be able to use this because it would be missing an arrow. So it's visually easier to see if you have everything you need to have to prove something this way. And then after a while, just think of these things like training wheels. At some point, you'll be able to do it in your head, and you'll know, like, oh yeah, I got all three, and you don't need something to visually see it anymore. Okay? All right, so try one on your own, or between you guys in your group, and go it all the way through this time. And you'll see you probably can do these a lot faster than I'm doing them because I'm explaining every little step. So go ahead and give that a try. So you probably noticed that you need to apply one small detail here when you're using this definition of segment bisectors. So this is clear. It says this segment bisect each other, right? So that means since this segment is bisecting this segment, these two are congruent, right? So we do know from there that CA is congruent to AY, right? But also we know that this segment is bisected, so this is congruent to this. So we can use this theorem twice, and it gives us two statements.
What about CAZ and RAY? Or CAR?
Yep, that comes up next.
What if you get both of those? I don't know.
As long as it's there. And then what is the third third one that we need. What else is congruent here just by looking at the picture? By the vertical angle theorem, right? We know that these are congruent to each other. So this is the angle of our side angle side. We have a side here. We have a side here. So we can use, if I had more than one of these, I could actually put it twice and not have two arrows come out of it, but that's the idea. You can use any theorem as many times as you want if it gets you what you need. You're not restricted of, okay, you used it, you can't use it anymore. It's like as many times as you need, it's fine. Okay? There we go. Look at that first problem and what that should look like on your homework. All right. So up here, you see, what you can write out. Now, you don't have the actual cards, but you could just draw a box, write reflexive property in there, congruent statements, draw the postulate or theorems for the triangle congruencies, just with the rounded edge here, just like they are on the proof blocks, and then what it's actually proving. Remember that here, they actually should match. Okay? What you're proving is your last step at the very end. So use the blocks. Don't cut them out from the paper, but just use them to know, well, what's going in, what should be coming out, and drawing all three that go into the three-part triangle congruence theorem or postulate. Okay. Now, traditionally, these take a little bit of work, so just know it's going to take a little effort. They are worth a lot more points than regular standard homework, so make sure you do come with a lot of it finished. I guarantee if you show up tomorrow and, oh, I didn't get it, you're going to be in really bad shape. So it'll take a lot of effort outside of class. Math Lab is open to J216, Monday, Tuesday, and Thursday. Got Homework Center, Monday through Friday after school. Okay, there's the internet. There's a lot of videos on doing even proof blocks. If you YouTube, using proof blocks, there's plenty of information there. So use all those tools to help you out. Okay. So, and then tomorrow we'll transition to using the two-column proof and what comes after this, so we can really make it a formal proof. Okay. Any questions before we go? All right.